Hello and welcome to Project Ventive. Today we are going to talk about the R1 Lunar Robot. But before we do that, make sure to like, share and subscribe to our channel for more informative content like this. Let's get to it. A lunar robotic rover, such as the R1, is a type of robot that is designed to travel on the surface of the Moon. These rovers are typically equipped with a variety of instruments and tools, such as cameras, drills, and spectrometers, that allow them to explore the lunar surface, collect samples, and perform scientific experiments. The R1 robot, developed by Gitai, is a multifunctional lunar rover that is specifically designed for lunar exploration, mining, inspection, and sampling. It is able to travel long distances on the lunar surface, navigate rough terrain, and perform various tasks using its specialized tools and instruments. It has a very high mobility and stability, able to climb steep slopes and drive on rough terrain. R1 also has the ability to perform autonomous navigation and obstacle avoidance. Additionally, R1 robot could be equipped with a variety of payloads, such as cameras, drills, and spectrometers, to allow it to perform a wide range of scientific experiments and measurements. Overall, the R1 robot is a highly advanced and versatile piece of technology that could greatly aid in the exploration and understanding of the lunar surface. Features of the R1 Lunar Robot. Here are some of the key features of the R1 Lunar Robot that was described above. Multifunctional. The R1 robot is designed for lunar exploration, mining, inspection, and sampling. High mobility and stability. The R1 robot is able to climb steep slopes and drive on rough terrain, providing high mobility and stability. Autonomous navigation and obstacle avoidance. The R1 robot is able to perform autonomous navigation and obstacle avoidance, allowing it to navigate the lunar surface without human intervention. Variety of payloads. The R1 robot is able to be equipped with a variety of payloads, such as cameras, drills, and spectrometers, to allow it to perform a wide range of scientific experiments and measurements. Long-distance travel. The R1 robot is able to travel long distances on the lunar surface, allowing it to cover large areas and explore remote regions of the Moon. Specialized tools and instruments. The R1 robot is equipped with a variety of instruments and tools that allow it to explore the lunar surface, collect samples, and perform scientific experiments. High performance. R1 robot is designed to work in extreme conditions, be it high temperature, low temperature, radiation and dust. Durable. R1 robot is built to withstand the harsh conditions of the lunar environment, and is made with materials that are resistant to wear and tear. These features make the R1 robot an advanced and versatile tool for exploring and understanding the lunar surface, and for conducting scientific experiments and measurements. Advantages of R1 Lunar Robot over other similar ones. The R1 Lunar Robot, as described above, is a highly advanced and versatile robot specifically designed for lunar exploration, mining, inspection, and sampling. Therefore, it likely has some advantages over other similar robots. Here are a few examples. Mobility and stability. The R1 robot has high mobility and stability, allowing it to navigate rough terrain and cover large areas of the lunar surface. This makes it well suited for exploring remote regions of the Moon that have not been explored before. Specialized tools and instruments. The R1 robot is equipped with specialized tools and instruments, such as drills and spectrometers, which allow it to extract valuable resources from the lunar surface and perform scientific research. Autonomous navigation. The R1 robot can perform autonomous navigation and obstacle avoidance, allowing it to move around the lunar surface without human supervision. Supporting human exploration. The R1 robot can be used to support human exploration by performing tasks that are too dangerous or impractical for humans to do. Teleoperation. The R1 robot could be controlled remotely by human operators on Earth, enabling researchers and scientists to perform experiments and collect data from the Moon in real time. Cost-effective. The R1 robot would be a cost-effective solution for lunar exploration and mining, as it can perform tasks without the need for human presence, reducing the cost of human spaceflight and enabling more frequent and longer duration missions. Advanced sensors. R1 robot is equipped with advanced sensors such as LiDAR, camera, and infrared sensors that would allow it to accurately navigate and map the lunar terrain, and identify potential resources or hazards. Robustness. R1 robot is designed to be robust and able to operate in the harsh conditions of the lunar environment, such as extreme temperatures, radiation, and dust, making it a suitable candidate for long-term missions on the lunar surface. Drawbacks of the R1 Lunar Robot above. As an advanced and versatile robot, The R1 lunar robot described above likely has many benefits and potential applications. However, like any technology, it also likely has some drawbacks. Here are a few examples. Cost: developing, building, and launching a complex robotic system like the R1 robot is likely to be quite expensive. This could make it difficult for some organizations or countries to afford. Limited autonomy: the R1 robot is described as being able to perform autonomous navigation and obstacle avoidance. However, the level of autonomy it can achieve is limited compared to humans' capability, and it still needs human supervision and guidance. Dependence on communication: the R1 robot would likely need to communicate with Earth-based control centers in order to receive commands and transmit data. This means that it would be dependent on a reliable communication link, which could be disrupted by solar flares, atmospheric conditions, or other factors. Limited lifespan: the R1 robot would likely have a limited lifespan, due to the harsh conditions of the lunar environment, such as extreme temperatures, radiation, and dust, which can cause wear and tear on the robot's systems. Limited payloads: the R1 robot's payload capability is limited, and it may not be able to carry all the necessary instruments and tools for all tasks, meaning additional missions and vehicles would be needed for complete exploration. Maintenance and repair: the R1 robot would require regular maintenance and repairs, and it would be difficult to perform these tasks on the lunar surface. Limited power supply: the R1 robot would likely be dependent on a power supply, such as solar panels, which may not provide enough power for the robot to operate for long periods of time, especially in the polar regions of the Moon, where the sunlight is scarce. Safety and security: the R1 robot would need to be able to operate safely and securely, to avoid any accidents or incidents that could cause harm to the robot, other equipment, or the environment. Real-life applications of the R1 lunar robot. The R1 lunar robot, as described above, is a highly advanced and versatile robot specifically designed for lunar exploration, mining, inspection, and sampling. Therefore, it has many potential real-life applications in these fields. Here are a few examples. Lunar Exploration: the R1 robot's high mobility, stability, and autonomous navigation capabilities make it well suited for exploring the lunar surface. It can cover large areas and navigate rough terrain, allowing it to reach remote regions of the Moon that have not been explored before. Lunar Mining: the R1 robot's specialized tools and instruments, such as drills and spectrometers, can be used to extract valuable resources from the lunar surface. This could include mining for rare minerals, ice, and other materials that could be used to support human exploration and colonization of the Moon. Inspection and maintenance: the R1 robot's cameras and other sensors can be used to inspect and perform maintenance on lunar bases, outposts, and other infrastructure. It can detect and report on any damage or issues, allowing for prompt repairs and maintenance. Sample collection and analysis: the R1 robot's specialized tools and instruments can be used to collect samples of the lunar surface and subsurface, and analyze them for scientific research. This could include studying the geology, geochemistry, and mineralogy of the Moon, as well as looking for signs of water or other resources. Supporting human exploration: the R1 robot can be used to support human exploration by performing tasks that are too dangerous or impractical for humans to do. This could include scouting out potential landing sites, setting up equipment and infrastructure, and collecting samples for human explorers to study. Teleoperation: R1 robot could be controlled remotely by human operators on Earth, enabling researchers and scientists to perform experiments and collect data from the Moon in real time. Cost-effective: R1 robot would be a cost-effective solution for lunar exploration and mining, as it can perform tasks without the need for human presence, reducing the cost of human spaceflight and enabling more frequent and longer duration missions. Thank you for listening. Don't forget to like, share and subscribe to our channel. See you in the next video.